Yo, what up, Sci-Fam? It's your boy Nickel. Let's define some physics vocabulary terms. We will define energy, force, the difference between potential energy and kinetic energy, and friction, and we'll end by defining the law of conservation of energy. So, speaking of energy, let's first define energy. Energy is going to be a measurement of an object's ability to do work. And work could be defined as this process when you apply a force and then that actually creates some type of motion. It's actually going to be when you transfer energy, but I was trying not to use the word energy by defining the word work, because work's in our definition already. But work is really just like this transfer of energy to an object by using a force, and then the object moves in the direction of that force. And so we can just summarize it there by saying that work is basically applying a force and then it causes some type of motion. And so energy can be measured in different ways. Now, we don't have to actually have motion happen. It might just actually be a buildup of something that could create motion. So as we move on, we'll talk about the differences between those two things. Now, there's different forms of energy. One type of energy, if something is in motion, it's said to have energy. Sound is actually a process in which air particles, air molecules, bump into each other. And they bump into each other until they reach your ear. And then they bump into your eardrum, which that's just a drum. That's not your eardrum. But you get the point. So sound is actually a form of energy. And you can think when you have a lot of noise coming into your ear, that energy can destroy your eardrum. Don't want that to happen. So sound's a type of energy. Light is also a form of energy. Another would be thermal or heat energy. And that is actually air molecules or water molecules. Whatever the molecules are, the slower they're moving, the cooler an object is, and the faster they're moving, the hotter something is. So this is a kind of interesting idea that on the molecular level, when things are hot, it's actually just that these air molecules or the water molecules or the hot cocoa molecules are just bouncing around super fast. They have a lot of energy, and that's what we call heat or thermal energy. An electrical field is also considered to be a form of energy, as well as a magnetic field. And you've probably felt that before. If you've ever tried to put two magnets close to each other, they get suctioned closer to each other because there's that field, meaning they're not touching yet, but they're pulled closer to each other. Or if you put them opposite, then they're going to repel each other. So those are examples of different forms of energy. Now, earlier on, I was talking about forces when we were defining the term work as we were defining energy. But a force is basically just any time that you push something or you pull something. So a push or a pull. You can either pull something up off the ground, you could pull it across the floor, you could push something towards your friend, you could push it into a hole. There's different ways that we use push and pull, but the overall vocabulary term in physics is just called a force. And a force, a push or a pull, is going to be described by two things. It's strength. You know, if you just barely push on a wagon, it might not move. But if you push harder and apply more strength, then it might move. So strength's important. And also direction is important as well. If you barely push it to the left, it might not move to the left. But that direction is important because if you're trying to get it to the right, then hey, you shouldn't be pushing it to the left, you should push it to the right. So whenever we have forces, we need to also talk about their strength, the strength of the force, and the direction of that force. Now, when I was talking about energy, I said there's different types of energy, and we talked about different flavors that energy comes in, whether it's sound or thermal. But there's two states that energy can be in, and that's either the potential to do energy, and so we call that potential energy, or there's the opposite of that, meaning that it's not just sitting in motion or not sitting in motion, because you can't be sitting and in motion. But if something's about to do work, that's potential. If it is actually doing work and showing that it has energy and it's in motion, then we have this idea of kinetic energy. So we're going to define these two. So potential energy is, well, we say it's the stored energy. It's a stored energy within a system. And we say within a system because you can imagine if you're pulling back a bow and arrow, there's a lot of different aspects of how you could build energy. You have to use your muscular energy in your body to pull the string back. But if we're just talking about the bow and arrow, then we could talk about the fact that the bow has some stretch in it, and there's a string, and when you then pull that string back, it actually has energy in the actual string. And so we could talk about the fact that before you let go of the string has potential energy in it, and then when you let go of it, it's going to create what we're going to define next, which is kinetic energy as that arrow moves forward. Now, potential energy has a very simple mathematical equation that allows us to see how you can change potential energy. So the abbreviation for potential energy is P sub capital E. The capital E on the bottom stands for energy, the P stands for potential, and the potential energy can be calculated by multiplying the mass of the object times the force of gravity times the height that the object is off the ground. So we could say P sub E is equal to M times G times H. But I do want to add one last little point of information here. See, when we pulled back this bowstring here, we didn't increase the height, but we did move it from its resting position. So therefore, sometimes height isn't necessarily the best term, but instead we could say this is like the displacement, because you could think about when we moved that bowstring, it was displaced from its resting position. If you pull back a slingshot, you displace it from its resting position. And so we would put that value here in the height. But it's also true that the higher up a ball is off the ground, the more potential energy it has. And that's just if it's on like a shelf or something, meaning it has the potential to fall off that shelf. And the higher up it is, the more energy it's going to have if it did fall. All right, so if it falls, then that's now kinetic energy. The potential energy is stored, and when we release that stored energy, like we shoot that arrow out of the bow, or this ball falls off the shelf, it's now in motion, and that motion is basically, it is called kinetic energy. So kinetic energy can be defined as the energy of motion. And if we were to abbreviate that, we could say it's a capital E, actually. I'm sorry, no, I had that right. It's a capital K, and then the letter in the subscript is E. So you can see this is the abbreviation for potential energy. That's the abbreviation for kinetic energy. All right, moving along here. Next we have the law of conservation. And if you ever think about the word conservation, people who are conservationists, they're trying to save things. So law of conservation of energy. And so you don't want to get rid of things. You don't want to destroy anything if you're into conservation. So we can use that to define the law of conservation of energy, and it just simply states that energy cannot be created, it can't come from nowhere, or destroyed, and it can't just disappear into nowhere. So it can't be created from nowhere, and it can't disappear into nowhere. It's only going to be transferred from one form to another. So when we did have that bow with the arrow in it, when we pulled back the string and the arrow is in there, here we're using our muscular energy to pull back on the bowstring. Then when we release our hand, our muscular energy, the string is going to push forward on the arrow. That energy is transferred from the string into the arrow as the arrow flies forward. Now this arrow is in motion, and now it has kinetic energy. But this potential energy here was transferred into kinetic energy. So therefore, the energy wasn't created from nowhere for that arrow to fly. It was transferred from our muscles to the string, from the string to the arrow. The arrow goes forward. And then when you hit the target, right in the bullseye, dong, that energy is transferred into the target. And actually, the arrow usually goes through the target a little bit because there's so much energy. It transfers to the target, and it keeps going until there's enough friction in the target to make that arrow stop. So friction can be defined as a force, a push or a pull, between two surfaces that prevents any type of slipping and sliding. So when you freshly pledge your wood floors at home, there's a lot of slipping and sliding, so there's very little friction. However, it's very hard to slip and slide across a carpet floor because the carpet has a lot more friction. It's a force that's between your socks and the carpet that prevents your slipping and sliding on carpet. And this can be applied to a lot of different types of surfaces. And so these are our physics vocabulary that allow us to have more in-depth conversations about physics by using the appropriate vocabulary terms. That, ladies and gentlemen, is your introduction to physics vocabulary.